Howdy, Abby. It's Miss Kosh. We were looking at some of these proof by exhaustion problems. And number 4, I realized that the answer key that I had, I don't really do proof by exhaustion. I mean, I guess, but I don't think that there's anything wrong with that. They told us prove that n squared minus 1 is divisible by 8 for all odd integers. So on my answer key, which is right here, what I did is I just said, okay, how do I describe all odd integers? Well, 2k becomes even. So anytime I take any integer at all and multiply it by 2, we now have an even number. If I add one more to it, now I'm an odd number. Okay, so 2k plus 1 is a way that we can describe all the odd numbers. So then when I plugged that in, I ended up coming down to this, where I have 4k times k plus 1. Well, and so what happens here is that k and k plus 1 are adjacent numbers. So one of them has to be even. Well, they're adjacent integers, okay? So we're living in the world of integers for all of this. And so if one of them has to be even, which means that one of those is divisible by 2, we already see this 4 right here. And so the whole thing is divisible by 8. I think that that's a fine way to write the proof. It doesn't quite feel like proof by exhaustion, though. So I went ahead and said, okay, well, how would we prove it by exhaustion? And so I said that all odd integers could be written as 4k plus 1 or 4k minus 1. So this one right here, 4k plus 1, when I plug in 0, I'm at 1. When I plug in 2, or 1, when I plug in 1, I'm at 5. When I plug in 2, I'm at 9. When I plug in 3, I'm at 13. Okay, so this becomes an arithmetic sequence of from 1, 5, 9, 13. And actually, since k has to be an integer, it's not, I mean, saying it's an arithmetic sequence kind of gives us an idea of what's happening, but really and truly, it would have all the integers going in the opposite direction too. So it's not an equal translation to being arithmetic sequence, because typically we only plug in, like if I had said a sub n is equal to 4n plus 1, we would have plugged in starting at positive 1 to infinity with integers. My scenario here is that not only does it do positive, but it also does negative. But okay, anyway, kind of trying to connect these ideas for you. So on this one, and the other scenario is 4k minus 1. If I plug in 0, that's negative 1. If I plug in 1, that's 3. If I plug in 2, that's 7. If I plug in 3, that's 11. Notice I've kind of got two nestled sequences. So I'm going negative 1, 1, 3, 5, 7, 9, 11, 13. And so I've got all of the odd numbers kind of written out into two different sequences. Okay, so that would be one way that we could look at this. So then I said here, well, let's pick one of them. Let n equal 4k plus 1, where k is an element of the integers. So then I plug that in. They had told me, oh, I should have written the directions. Here were the directions. I plug that in to n squared minus 1. I FOIL, I clean it up, and I can factor out the 8, therefore proving that the whole thing is divisible by 8. So I've done one scenario, and now I need to consider the other. Okay, and so the other, I did that 4k plus 1. Now I could have used 4k plus 1 and 4k plus 3. That would be fine. I just felt like working with smaller numbers. I also, if I have 4k plus 3 would generate the same terms as 4k minus 1, just not, you'd have to use different k's, but you would get the same sequence. Okay, sorry, that's whatever. Okay, so I plug this in, I clean it up, and then once again I can factor out an 8, showing that the whole thing is divisible by 8. So therefore we conclude, therefore, this is true for all odd integers. Okay, hopefully that was helpful. I would say if they tell you to use proof by exhaustion, then you could do this option. We could also use option 3. Would be to use 8k plus 1, 8k plus 3, 8k plus 5, and 8k plus 7, because that's going to also generate all the odd numbers. And then when you square, this is not a formal proof, I'm just giving you an idea. 8k plus 1 squared minus 1, that becomes 64k plus 16k plus 1 minus 1. So this cleans up. It's just that it's bigger than we need it to be. Okay, so using the 4 back here, the 4k minus 1 and the 4k plus 1, we had less scenarios to consider, and we had smaller numbers to work with. Hopefully that was helpful. Go practice.